live from the 2019 Wolfram Technology Conference. I'm Sylvia Haas, and I'm Wolfram Alpha on Twitter. And I'm here with my co-host.
Hi, I'm Rachna. I'm a student at the Illinois Math and Science Academy, and I'm part of the Wolfram Emerging Leaders Program. I'm here with Carlo Barbieri, who is a consultant for Wolfram, who's going to tell us all about relational databases.
Hi.
So, what do you do at Wolfram?
Oh, I've been here a few years now,
Okay.
8, and I've done a number of things. First started out in Alpha, then moved on working on the Wolfram language itself, did some stuff for the cloud, and now the last and greatest project that we've been doing is about integrating SQL databases in the Wolfram language. Most of the functionality came out with version 12 in April, and so we're trying to replace what was database link, that was a separate package for interacting with SQL. And as it's very common in the Wolfram language, sometimes features start out as separate packages, and then we integrate them more closely with the rest of the language, and so they become, when this tighter integration and more polished design, we finally understand better what people need, then we bless them as system packages. And this is what happened. It's been, I have to say, one of probably the largest projects I've worked on. I work with Carlo Barbieri, who's another developer who works in Rome, where I am based, and with Leonid Shivrin, who is from St. Petersburg. Leonid is a very long-time Mathematica user. He's written one of the best books, and it's really been an honor to work with this team. Relational databases are one of the most mature and long-standing technologies in computer science. Now, there's been a trend maybe 10 years ago where people wanted to stop using SQL and start using NoSQL, but then SQL made a comeback. And now it's been SQL has been around for 40 years, and there's people basically every website you touch has an SQL database behind it, and everybody who does data science uses SQL. It's a truly marvelous technology, but it has a lot of rough edges. There's multiple database vendors with slightly different dialects. And so basically, for somebody who approaches SQL from the outside, it can be a bit daunting. And so what we're trying to do is to bring a layer of abstraction to actually allow people to interact in the same way with databases such as SQLite, which is file-based and usually is tiny, to things like Postgres, which can be of the order of terabytes of data. So it's the first time that Mathematica has some truly out-of-core data science capabilities, and we think it's cool.
Yeah, that sounds awesome. Sounds very cool. So what type of person would use this?
Well, so for now we only support reading from databases.
Okay.
So what you do is, for example, there's a large number of public data sets in, for example, computational biology or bioinformatics.
Okay.
So things like gene expressions and proteins, they have these very large data sets that cannot possibly fit in the memory of your computer. So the only way to interact with them is to perform some queries on the database. Then what our system allows people to do is to have some kind of a hybrid approach to this kind of data science. So you first aggregate or filter the data to a manageable size.
Okay.
And then you can bring it into Mathematica, and then you can do all the crazy things that Mathematica is able to do in terms of visualizations and data analysis. So it's our stuff is the first step in bringing data into a manageable size, taking it in. So I imagine anyone who's data scientist or work with large amount of data, and actually the path forward is to allow this stuff to be available also to people, for example, who want to develop their websites on Wolfram Cloud, and so it would be useful also for example, if you have a form and you want to log the people coming in and filling it in, databases are the tool of choice for collecting data as well. So as soon as we support writing, then there will be also that big segment of users.
Okay, awesome. So Okay. Yes. So how can this be like integrated with projects like now? Like if you want to learn about it, is there places to do this?
Yeah, so, well, one good place to, so there are two good places to start
Okay.
for your own project. One is kind of more of a brief introduction, and it's, if you go to the wolfram.com webpage, there's, you can click on version 12, and it's going to bring you to all the marketing pages, and there's one on relational databases where there are a few examples that I wrote with Ricardo and Leonid. And for example, one of them is exactly about this gene expression databases, and it shows how basically how one would go and find a public data set to analyze and so on. The second path, which is more, I mean, it is a lot more in depth, is there is a tutorial about relational databases that has been written entirely by Leonid. And it's, I mean, I once tried to print it as a PDF file,
Okay.
and it's over 100 pages. So it's really more than a tutorial. It's really a small book about this functionality.
Okay.
And while it doesn't provide people with super interesting data, you have to bring your own data to do interesting things. But it has much more complicated queries, and it goes very much in depth into what is possible, what the limitations are, what are the tricks to do this efficiently. So strong suggestion is go read the documentation. Because as usual at Wolfram, we put a lot of effort in that. So,
Okay. Awesome.
yeah.
That's super cool. Have you, right, so you are building the technology behind it, right?
Yes.
But have you used it in any applications that you're excited about?
Well, one thing I am excited about, and it's something that I discovered while I was writing the documentation pages, is basically within the company we have a lot of functionality that is related to geographics. So I don't know if you have interviewed Francisco, but all the actual mapping functionality and plotting on maps, CorPlat and so on, is done using a software that is called, I mean, behind the scenes, is called PostGIS. And that's what OpenStreetMap uses.
Okay,
And
cool.
I assume also Google Maps uses that, but we don't know because it's a private thing. OpenStreetMap is open, so we know how it works. And so basically we have, inside the company, we have our own instance, our own copy of OpenStreetMaps to support all the things that we do with mapping.
Okay.
And so he gave me access to that because I wanted to write some example on some really big database, and that's over a terabyte. And I started playing with it. And at first, like when I was doing the marketing pages, I found some stuff that was interesting. Like I was counting how many trees are mapped throughout the world in the OpenStreetMap project, or I was counting how many streets with the Wolfram string within the name in some part existed. I found 200 and something. Obviously, I also did it with my last name, not just Wolfram. and so, but it was all very dry because all the actual mapping abilities were impossible to reach because those are actually extension to the SQL language, and they have like their own specific domain-specific language to do that stuff that obviously we can't support because it's supported only in that very niche thing. And what we've been doing recently, and which is something that we're going to add to version 12.1, is that we allow people to insert their own verbatim SQL strings in the middle of a more complex generated query. And so basically I started experimenting with the actual functions, and so now I can not only find the streets that contain Wolfram in the name, but I can actually compute the length, find the longest one, and then map it, because you can return a GeoJSON that Mathematica knows how to import. And so I think this is extremely, like, now that we are bridging the gap between the capabilities that everybody wants, and so we make them that simple to integrate, to the things that maybe work on a very niche vendor, and so we will never put there up and front, because then it will not work most of the time, actually. So it wouldn't make sense. You can start doing like really advanced data analysis on data sets that are thousands of times larger than the RAM on my machine, so that I would never be able to manipulate otherwise. So,
that's awesome. Right, so you mentioned being able to write and other things for the databases. Is there anything else that you're like working on for the future?
Well, writing to databases is really big project.
Yeah.
One of the projects that I worked before at the company was actually all the things that are related to API functions and form functions, interpreter that powers API function. And one thing that we want to do that we actually had in mind when we first started working with form function is that, in a sense, a form is a pretty close representation of a database row. So what we want to be able to do, but this is probably not going to be 12.1, it's going to be the following release, is to take, in our case, so a database table is usually represented as an entity type. Take an entity type, feed it to a form, and get out automatically a website for data entry.
Okay, awesome.
So what we want to do is like to bridge together a project that we started now 5 years ago, which is forms and APIs, which are largely the same thing. One is an interface for humans and the other is an interface for computers.
Yeah.
And use those to generate a very simple website that allows you to say, okay, let's say I have a customer database table and I need to fill in first name, last name, and then maybe I have a drop-down menu with the department they work for. So all those things are things that should be that simple to integrate together, because we've been designing them with a kind of a holistic approach, which I think is really one of Wolfram's strengths as a company. That, it's not like somebody is going in their own direction, somebody else is going in their own direction. There's like an idea that has been largely the same for the past 30 years about what the design of the language should be and what are the common principles and how all should fit together very tightly. So I'm very excited about this development, and I hope it will come out as good as we expect it to be.
Yeah, that sounds amazing. Well, thank you so much for coming in and talking
Thank you.
with us.
Thank you.